All right, hello, ladies and gentlemen. Today we're going to I'm going to go over some of the problems that were on the derivatives review homework. Now, I didn't really receive any feedback about like what problems you want me to go over, but in the future, I'll ask you which ones particularly seemed difficult, and I will go over those problems on the video. But I chose six problems that I thought were maybe a little bit more challenging than the others. So anyway, the first few we're just given a function and we're looking to differentiate with respect to x. All right, so here we have f of x equal to e to the x cubed to find the derivative, or in other words, to find f prime of x. We're going to need to use the chain rule because we have a composition of functions here. We have the function e to the x, and then that e to the x is being evaluated at x cubed. So to differentiate using the chain rule, we take the derivative of the outer function, which is e to the x, and evaluate it at the inner function, which is x cubed. And then we multiply by the derivative of the inner function. And there you have it, you're done. So, I mean, once you know the rule, it's simple, but this may not initially have been a rule that you recognize right away. All right, so that's that. Let's move on to the second one. All right, this one, of course, anytime trig is involved, you all get a little bit nervous, and not only is trig involved, but there's actually a composition of, two other functions. So there are a total of three functions here. There's ln x, there's cosecant x, and then there's 3x. All right, one inside of the other. So 3x is inside of the cosecant, and of course the cosecant is inside of the ln. So we have to take that into account when we are taking the derivative here. We need to use the chain rule twice. Okay, so y prime is equal to, well, we want to take the derivative of the outer function and evaluate it at the inner. So the derivative of ln of x is 1 over x. So to start, I'm going to write 1 over, and I'm going to evaluate at the inner function, which is cosecant of 3x. But now I have to multiply by the derivative of that inner function. So the derivative of cosecant of x is negative cotangent times cosecant, but it's actually negative cotangent x times cosecant x. But of course, this cosecant function is being evaluated at 3x, so I have to evaluate the derivative at 3x. And then I multiply by the derivative of that inner function. So the derivative of 3x is 3. All right. And of course, things cannot simplify kind of nicely here. We have a cosecant in the denominator and the numerator. Right? You could bring that 3 to the front, and you can write this as negative 3 times cotangent of 3x. And very likely, if this were a multiple choice problem, this is how you would see the answer written. So on short answer, no, you don't have to simplify necessarily, but it's good to get in the habit because multiple choice will typically simplify. All right, moving on. So this one's kind of interesting because we have a composition, right? We have the outer function of ln x, and then we have the inner function of e to the x over x squared. All right, so e to the x over x squared is inside of the ln of x. Now this e to the x over x squared, it's a quotient, so when we differentiate that, we need to use the quotient rule. All right, so this is going to get, it's going to be a little bit messy, but it's not too bad. So let's start. F prime of x is equal to, well, again, the derivative of that outer is just 1 over x, and in this case, x is the inner function. So 1 over e to the x over x squared. Now I have to multiply by the derivative of that inner function. Well, the quotient rule says to take the bottom function, multiply by the derivative of the top, minus the top function, times the derivative of the bottom, all over the bottom function squared. Okay. And actually, I'm going to write this in a simplified way. Let's see. This first term here, this guy on the left, can be written as x squared over e to the x. And let's see. This second term has an e to the x in both of the numerator terms, so I can factor that out. And this becomes e to the x times x squared minus 2x all over x to the fourth. Scrolling down a bit. And I'm going to simplify things. So this e to the x cancels with this e to the x. This x squared cancels with, well, some of these values. And finally, my final answer can be written as x squared minus 2x all over x squared. And you could simplify further if you'd like, but we will leave it here for this video's purpose. All right. Moving on. So I was asked a few times about this one, y equals 2 to the sine x. So once again, chain rule, get used to that, because typically if you're taking a derivative on the AP exam, it's going to be a chain rule, typically. So we have two functions here. We have 2 to the x, we have y equals 2 to the x, and we have y equals sine x. All right. Sine x, of course, is the inner function. Now, the big one that people forgot in SGI was, how do we differentiate something like y equals 2 to the x? Well, just some side work. If you just had y equals 2 to the x alone, its derivative, remember, is ln of 2 times 2 to the x. All right, so over here, when we have a composition like y equals 2 to the sine x, its derivative is going to be, well, we take the derivative of that outer function, so we would write it as ln of 2 times 2 to the sine x, and then we multiply, so that's the derivative of the outer function evaluated at the inner, and then we multiply by the derivative of the inner, and the inner function being sine of x, so the derivative of sine of x is just cosine of x. And there you have it. That's your final answer. Okay, so here's your second to last one. I just figured since we did the quotient rule before, we should also do the product rule. So like the three big rules are in this video: the chain rule multiple times, the quotient rule we saw earlier, and here will be the product rule. So y prime is equal to, so I'm going to do the derivative of the first times the second plus the first times the derivative of the second. Okay, and that's all, except for maybe simplifying some. So there's an e to the x term in both of these terms, and so I'm going to factor that out, and I can just rewrite this. I could write this as e to the x times 2x plus x squared. Boom. And there we have it. And let's move on to this multiple choice problem. So like I mentioned, I took these directly from these from AP Classroom. So these are like supposedly publicly available problems. And this is like something that you might see on the AP. And I believe that this was a non-calculator problem. So we have to somehow decide, and I know it's actually kind of hard to read, but what this says is at x equals 3, the function is given by this expression, this piecewise expression. And we want to determine if this function is undefined at x equals 3. Is it continuous? Is it differentiable? Is it neither? So on and so forth. So let's start out with testing continuity. So remember, continuity requires that f of a exists. The limit as x approaches a of f of x exists, and that these two numbers are the same. Okay, so we need to test those three things. So let's see, using the piecewise defined function, f of 3, well, this function is defined at the lower branch for x equals 3. So I'm just going to plug 3 into 6x minus 9, and that will be 9. Okay, now to go on and test to see that the limit exists. Well, since this function is defined, since there's a lower branch and an upper branch, and those branches happen to split exactly at x equals 3, when we do the left-handed limit, we're going to use direct substitution on the upper branch. When we do the right-handed limit, we're going to do direct substitution on the lower branch. So to test the limit as x approaches 3 from the left of x squared, I'm going to use direct substitution on that lower branch, and that equals 9. So I know the left-handed limit is 9. Now let me test the right-handed limit. And we just saw before that direct substitution on this lower branch gives us 9. And the fact that the left-handed limit and the right-handed limit agree, this implies that the limit as x approaches 3 of f of x of the overall function is equal to 9. All right, so f of a exists, the limit as x approaches a of f of x exists, and we can clearly see that those two numbers are equal to one another. So therefore, this function is continuous at x equals 3. All right. Now we need to check differentiability. Well, in order to check differentiability, we're going to do something very similar, but for the derivative function. So let's take the derivative of our piecewise function. The top branch, the derivative of the top branch is just 2x. So this is going to be the derivative for values of x less than 3. The derivative of that bottom branch is just 6. And this will be the derivative for x values that are greater than or equal to 3. And we're going to check the same three conditions. Does f, in this case, is f prime of a exist? Does the limit as x approaches a of f prime of x exist? And are those two numbers equal to one another? Well, f prime of 3 is just going to equal 6. Okay. Left-handed limit as x approaches 3 of f prime of x. Direct substitution in this top branch gives me 6. Oh, I should say 3 from the left. And limit as x approaches 3 from the right of f prime of x. Well, now that will be the bottom branch, and we see that that is equal to 6. Those two limits are the same, so the left and right-handed limit agree with one another. Therefore, the overall limit is equal to 6, which means that the value of the function, in this case, the derivative function at x equals 3 is equal to the limit of the derivative function, there should be a prime there, is equal to the limit of the derivative function as x approaches 3. And therefore, the derivative itself is continuous. So if the derivative is continuous and the original function is continuous, we have a function that is differentiable at that point, x equals 3. Not only is it differentiable, it's differentiable and continuous, of course. So choice E would be the correct choice. All right, ladies and gentlemen, I hope that was helpful to those of you that decided to watch. When I post my next assignment, I'm going to ask that you sort of suggest which problems you'd like me to go over in the next video. That way, you know, I'm going over problems that you're asking for and not ones that I just think you might want me to go over. But anyway, hopefully this was helpful. But if there was a problem that I didn't cover that you were a little unsure of, feel free to mention it and I will happily go over it in the next video. All right, ladies and gentlemen, hope you enjoyed. And I'm trying to stop record. And there we go. All right, take care. See you soon. Well, I'll talk to you soon. I don't know about see you soon, but talk to you soon. Bye.